In the blink of an eye, someone's life can change forever. A second of inattention. An exposed part. A rule ignored. I'm Eric, the workplace safety guy, and today, we're not just going to talk about regulations. We're going to talk about the fine line between safety and catastrophe. About what really separates an efficient and safe industrial operation from a multi-million-dollar lawsuit and a destroyed life. If you have machines, if you operate them, or if you design them for the most demanding market in the world, the United States, then what I'm about to show you is not just important. It's existential. It's the difference between the success and failure of your business, between the integrity of your workers and ruin. Most people think safety is bureaucracy. I'm going to prove to you that it's your greatest shield. We're going to dive deep into the intricacies of OSHA regulations and ANSI/ASME guidelines, not as a boring manual, but as a map to avoid the worst industrial nightmares. Forget everything you think you know about machine guarding. Because, in the next few minutes, you're going to discover the secrets that major industry players use to stay safe, profitable, and above all, guilt-free. Stay with me. Your safety, and the safety of those who work with you, depends on it. Let's be honest, accidents happen. And machines, oh machines. They are the driving force of our industry, our economy, but they are also potential sources of unimaginable dangers. Think with me, a pinch point that grabs a hand, a belt that pulls a sleeve, a rotating shaft that snags hair, a part ejected at high speed, a deep cut from an unguarded blade. The list of horror scenarios is long and unfortunately, real. I myself have seen situations that sent shivers down my spine. They weren't fatal, but they were incidents that, by a narrow margin, didn't turn into tragedies. I remember once, during a factory visit, an operator, due to a second of distraction, almost had his hand pulled into a conveyor roller. The guard was there, but it was damaged and didn't work as it should have. That left a deep impression on me. And it made me realize that in the workplace, where risks are multiplied and constant, protection is not a luxury, it's an absolute necessity. In the United States, statistics are clear. Machine-related injuries are a common occurrence and are consistently among the leading causes of serious accidents and fatalities in industry. Thousands of workers suffer amputations, fractures, lacerations, and other disabling injuries each year, many of which could be prevented with adequate machine guarding. That's why this conversation is so important, and that's why we need to understand the standards that govern this protection. My first stop in this investigation was, of course, OSHA. For those unfamiliar, OSHA, the Occupational Safety and Health Administration, is the federal agency in the United States with a clear mission: to ensure safe and healthy working conditions for all American workers. Think of it as the great guardian of workplace safety. I started reading the documents, the regulations, and I realized that OSHA is not just a body that tells you what to do. It is the driving force behind a safer workplace, and its regulations have the force of law. And when it comes to machine guarding, OSHA is very specific in its requirements, albeit in a general way. The main regulation I found, and which became the pillar of my research, is 29 CFR 1910 Subpart O, specifically Section 1910.212. For those not in the field, this might seem like a boring code, but for me, it was like deciphering a treasure map of safety. This standard, which applies to general industry, is crystal clear. Employers must ensure that all machines, regardless of type, that present a risk of injury, are guarded. And what are these hazards? OSHA lists some very clear ones: the point of operation, which is where the work is performed; pinch points, where two parts move together or one part moves near a stationary one; rotating parts, such as shafts and pulleys; and the projection of particles or sparks. But it also adds a comprehensive category: other hazards that may cause injury. This shows the breadth of the employer's responsibility. It's not just about the obvious, but about anticipating and mitigating any potential risk a machine might present. OSHA is not content with almost safe, it demands safe. Delving a little deeper into OSHA, I understood that the agency not only requires machine guarding, but also establishes fundamental principles for that guarding to be effective. And the first step in this process is crucial: hazard identification and assessment. Imagine yourself as an employer. You can't just put a fence anywhere and expect it to address all risks. OSHA requires you, as an employer, to look at every machine in your workplace with critical eyes. What specific risks does each machine present? Are there cutting points? Crushing points? Exposed rotating parts? Is there a risk of material ejection? This detailed assessment is what will guide the choice and design of the right guard. It's like a doctor diagnosing an illness before prescribing medication, but here, the medication is the guard. OSHA requires guards to be affixed to the machine whenever possible, so they cannot be easily removed or bypassed. They must not create new hazards, such as sharp edges or additional pinch points. And fundamentally, they must prevent any part of the operator's body from entering the danger zone during the machine's operating cycle. This means the guard must be an effective physical barrier, not just a warning. And here comes OSHA's famous 7-foot rule: any moving part, such as pulleys, belts, gears, shafts, that is located less than 7 feet, approximately 2.13 meters, from the floor or working platform must be protected by physical barriers. If it's above 7 feet, OSHA generally considers it out of normal reach, unless there's an elevated platform. But below that limit, guarding is mandatory, period. This is a serious commitment to safety, and the responsibility for ensuring these guards are in place and functioning lies with the employer. And it doesn't stop there. The employer is also responsible for ensuring that guards are maintained in safe and operational condition. A damaged guard does not protect. And of course, training. What good is the best guard if the worker doesn't know why it's there, how it works, or how to identify when it needs maintenance? OSHA thinks of all this, and I found that very intelligent. While OSHA tells us what to do, it doesn't go into the details of how a guard should be constructed to be effective. That's where technical standards come in, and my discovery of ASTM International and, more importantly, ANSI and ASME. These were some of my biggest discoveries, and it's where the science and engineering of safety truly shine. ASTM International, formerly known as the American Society for Testing and Materials, is an organization that develops consensus standards. Think of them as the engineers of safety. They create detailed performance criteria and test methods for a multitude of products, including machine safety components. OSHA, in its wisdom, refers to these standards. It says, employers, you need guards that protect against impact, compression, etc., and these guards must comply with recognized industry standards. And this is where ANSI, the American National Standards Institute, and ASME, the American Society of Mechanical Engineers, come into play. ANSI does not directly develop standards, but it oversees the development of standards by other organizations, such as ASME, and approves them as American national standards. ASME, in turn, develops a vast range of codes and standards, many of which are crucial for machine design and safety. When I began to understand the relationship between OSHA, ANSI, and ASME, it was like a new language opened up to me. Each standard, each specification, has a profound meaning in terms of protection. Now get ready, because we're going to decipher the secret language of machine guarding. When you deal with machinery in the US, you'll find references to standards like ANSI B11, 0, ANSI B11, 1, ANSI B11, 2, and so on, depending on the type of machine. These standards are not just numbers, they are the result of years of engineering, testing, and lessons learned from accidents. ANSI B11, 0 is the umbrella standard for machinery safety. It establishes the general principles for risk assessment and risk reduction in machinery. It is not specific to a type of machine but provides the methodology. It requires both manufacturers and users to identify hazards and implement measures to reduce risks to acceptable levels. This is done through a rigorous risk assessment process that includes hazard identification, such as cutting, crushing, entanglement, ejection, electrical, thermal hazards, etc., risk estimation, evaluating the likelihood of a hazardous event occurring and the severity of the resulting injury, considering the frequency of exposure and the possibility of avoiding the hazard, risk evaluation, comparing the estimated risk with acceptable risk criteria, and finally, risk reduction, implementing control measures according to the hierarchy of controls. The hierarchy of controls is a fundamental concept that ANSI B11, 0 promotes. It tells us which type of risk control we should prioritize, starting with the most effective. Elimination/substitution, the first and most effective step. If you can eliminate the hazard completely, for example, redesign a process so that there is no need for a dangerous moving part, or replace a hazardous component with a safer one, do it. It is the ideal solution. Engineering controls. This is where machine guarding fits in. These are physical solutions that separate the worker from the hazard. Fixed guards. These are preferred and most effective. Permanent barriers. bolted, welded, or firmly attached to the machine, that completely prevent physical access to the danger zone. They are robust, difficult to remove without tools, and do not depend on operator action. Interlocking guard/devices. Guards that shut down the machine or prevent its operation if opened, removed, or if an access door is opened. An interlock ensures that the machine cannot operate unless the guard is in place and closed. They can be mechanical, electrical, magnetic, or RFID. Presence sensing devices. Sensors that detect the presence of a person or body part in a danger zone and stop the machine or prevent its cycle from starting. Light curtains, pressure-sensitive mats, laser scanners, and radio frequency barriers are examples. They are great for areas where frequent access is necessary, but they require maintenance and calibration. Administrative controls, procedures, policies, training, and signage that inform workers about hazards and how to avoid them. Examples include lockout/tagout, LOTO procedures, work permits, job rotation to reduce exposure, and safety signage. These controls depend on worker adherence and are therefore less reliable. Personal protective equipment, PP, the last in the hierarchy. They should be used as a supplement, never as the sole form of protection. Safety glasses, gloves, hearing protection, hard hats. PP protects the individual but does not eliminate the hazard at the source. Beyond B11. 0, we have more specific standards. ANSI/ASME B15. 1, for example, is crucial for mechanical power transmission systems, such as shafts, couplings, belts, pulleys, chains, and gears. It goes far beyond OSHA's 7-foot rule, offering specifications for guard materials, openings and clearances, fastening and mounting, ergonomic design, and requirements for guarding different types of components. It details the minimum safe distances that must be maintained between the guard and the moving part to prevent access, and the maximum sizes of openings in guards. This is fundamental to ensuring that a guard is truly effective and cannot be bypassed. Other standards in the ANSI B11 series are specific to machine types, such as mechanical power presses, B11. 1. Press brakes, B11. 3. Shearing machines, B11. 4. Drilling machines, B11. 8. And so on. Each of these standards provides technical details about the specific hazards of that machine and the most effective guarding solutions. For example, for mechanical power presses, the B11. 1 standard details requirements for point-of-operation guarding devices, such as barriers, presence-sensing devices, light curtains, two-hand control devices, and restraint or pullback devices. It also addresses the safety of control systems, interlocks, and setup and maintenance procedures. The beauty of these standards is that they allow us to combine different types of protection to create the perfect safety system for almost any machine and work environment. It is a very intelligent and effective approach to safety. With all these codes and standards in mind, I began to see machine guards not just as fences, but as complex engineering systems, each designed for a specific set of challenges. Fixed guards. This is the workhorse of machine guarding. Whether it's a metal enclosure, a robust wire mesh screen, or a polycarbonate casing, the fixed guard is the first line of defense against contact with dangerous parts. I see this in almost every sector, from automotive manufacturing to the food industry. It is the basic and most common protection, and the most recommended by the hierarchy of controls. For example, on a packaging machine, a fixed guard can cover the conveyor belts and gears that move the products, preventing accidental access. Interlocked guards. If access to the machine is necessary for material feeding, adjustment, or maintenance, but the machine still presents a hazard, interlocked guards are indispensable. They ensure that the machine cannot operate if the guard is open or removed. Think of an access door to a robotic cell. It will have an interlock that shuts down the robot immediately if the door is opened. This is fundamental in automated assembly lines or continuous processing machines. Presence sensing devices, light curtains, laser scanners for operations where the operator needs to interact frequently with the point of operation, but cannot have a constant physical barrier. Presence sensing devices are the solution. A light curtain on a stamping press, for example, creates an invisible barrier. If the operator's hand breaks the light beams, the press stops immediately. Laser scanners can create configurable protective zones around large machines, alerting or stopping the machine if someone enters the danger zone. Two-hand controls. On machines like presses or shears, where the operator needs to initiate the cycle, Two hand controls require both of the operator's hands to be on control buttons, away from the danger zone, for the machine to operate. This ensures that the operator's hands are safe during the machine's operating cycle. Restraint and pullback devices, less common nowadays, but still used in some applications. Restraint devices physically limit the movement of the operator's hands away from the danger zone. Pullback devices pull the operator's hands out of the danger zone when the machine is activated. While effective, they are more intrusive and may be less preferred due to operator comfort. Adjustable guards. For machines that process parts of different sizes, an adjustable guard may be necessary. It can be moved or adjusted to accommodate the material, but it must still provide adequate protection for the danger zone. For example, on a bandsaw, the blade guard can be adjusted to the height of the material being cut. Self-adjusting guards. These guards automatically adjust to the size of the material being processed. On a circular saw, for example, the guard can automatically rise as the wood is fed, and lower again when the wood passes, keeping the blade covered as much as possible. The beauty of these standards is that they allow us to combine different types of protection to create the perfect safety system for almost any machine and work environment. It is a very intelligent and effective approach to safety, which considers the functionality of the machine and the need for operator interaction. In my journey, I realized that safety is not a one-way street. It is a shared responsibility, a collaboration between the employer and the worker. On the employer's side, I've already mentioned hazard assessment and guard selection. But OSHA and ANSI go further. They require the employer to develop and implement a comprehensive machine safety program. This is not just about installing guards, it's about creating a safety culture. It's about ensuring that guards are designed, installed, and maintained correctly. It's about ensuring that workers know why the guards are there, how they work, how to use them correctly, and how to identify when they need maintenance or repair. And in most cases, the employer is responsible for the cost and maintenance of these guards. This is an investment in the lives and health of their employees, and in the longevity and reputation of their business. The employer is also responsible for implementing lockout/tagout, LOTO procedures to ensure that machines are de-energized and cannot be accidentally started during maintenance or repair. This is a fundamental pillar of machine safety. On the worker's side, but the worker also plays a fundamental role. It's no good for the employer to provide the best guarding system in the world if the worker bypasses it, removes it, or uses it improperly. My research has shown that OSHA and industry best practices expect the worker to use guards correctly. It's not an obstacle, it's a safety tool. Never remove or bypass a guard. Inspect guards regularly. Before each shift, a quick look can identify damage that compromises protection. A loose guard, a malfunctioning interlock, an obstructed light curtain, all of these can mean that the guard is no longer safe. Report problems. If a guard is damaged, missing, or not functioning correctly, it is the worker's duty to immediately inform their supervisor. Everyone's safety depends on it. Participate in training. Understanding machine hazards and how guards work is crucial for personal and collective safety. It's a partnership. The employer provides the tools and knowledge, and the worker uses them responsibly. When this partnership works, the workplace becomes exponentially safer, and accidents become rare events, not inevitable ones. As I delved into the standards, one thing became very clear to me: compliance with standards is essential, but it is not the only factor. Think with me, a machine guard, no matter how certified, will not protect anyone if it is so inconvenient that the worker is tempted to remove or bypass it. That's why ergonomic design and functionality are so important. A well-designed guard should allow necessary access for operation and maintenance without compromising safety. If the guard impedes workflow, or makes the machine difficult to operate, the temptation to bypass it increases exponentially. Durability and maintenance are also crucial points. A machine guard does not last forever. Natural wear and tear, exposure to chemicals, repeated impacts, vibration, all of these can compromise its integrity. That's why regular inspection, preventive maintenance, and replacement when necessary are so important. It's not about saving a few dollars, but about protecting a life and preventing an accident that could cost millions. And finally, I think about industry-specific requirements and emerging technologies. OSHA and ANSI standards are comprehensive, but some industries have even more specific needs. Think of machines operating in explosive atmospheres, which require guards made of non-sparking materials, or machines dealing with high temperatures, which need heat-resistant guards. The beauty of the American system is that it allows for this flexibility, encouraging the search for the ideal protection for each scenario, and is constantly evolving to incorporate new technologies, such as artificial intelligence and computer vision for presence detection and safe behavior. Machine safety is a dynamic field, and staying up to date with the latest standards and technologies is fundamental. We have reached the end of our journey, and I hope that you, like me, have a new appreciation for machine guards. They are much more than simple barriers. They are the result of years of research, testing, engineering, and regulations, all with a single purpose: to protect our workers, our productivity, and the integrity of our businesses. Machine guarding is, in many ways, an invisible protection. We don't think about it until something goes wrong. But the knowledge we have gained today gives us the power to see this protection, to understand it, and to demand it. Whether you are a worker, an employer, an engineer, or just someone curious about safety, I hope this video has shed some light. Check the safety requirements in your own workplaces. Look for references to ANSI and ASME standards. Understand what each specification means. And above all, prioritize safety. Your machines are valuable tools. Protect them with the right safety systems, which meet the rigorous standards of OSHA and ANSI/ASME. Because, in the end, safety is not a cost, it is an investment. An investment in lives, in well-being, and in a safer future for all of us. Now, the crucial question is, what are you going to do with this knowledge? Are you going to keep it to yourself, or are you going to turn it into action? I challenge you, review your machines. Look at them through the eyes of OSHA and ANSI. Identify the blind spots, the hidden risks. Share this video. Don't just click the button. Think about who needs to hear this. Your colleague, your boss, your supplier. Send it directly to them. Be the agent of change in your company. Leave your comment now. What was the point that impacted you the most? What is the biggest safety challenge you face? Your voice is fundamental for us to build a safer community. And if you are committed to excellence and safety, if you want to always be one step ahead, then be part of our community. Click the subscribe button right now and turn on notifications. Don't miss the next video, where we will delve even deeper into these topics that define the future of industry. Remember, ignorance is not an excuse. Prevention is the only strategy. Invest in safety, invest in your future. Thank you very much for your attention, for your dedication to safety, and for making a difference. Stay safe, and I'll see you in the next video.